Okay, so we are live already. Hello, everyone, and I want to welcome each of you to another VOLO Tech Talk discussion on the topic of mobile app development for IoT projects. Firstly, let me introduce the team on our side. So I'm Mariam from VOLO's marketing team, and I will be moderating the discussion today with my colleagues Andranik and Arman. They are tech specialists with extensive experience in mobile IoT development projects. So hi, guys.
Hi, Mariam.
Thanks for being here today with us. And now let me tell you the origination of this topic. So why we decided to focus on this particular topic. In addition to our expertise in IoT, we all noticed the fact that mobile apps enhance the functionality and usability of IoT devices, making them more accessible and useful for users. Most of us are already using such kind of apps for our daily lives to monitor, for example, smart vacuum cleaners, security cameras, etc., you name it. And it's interesting to observe some statistics and how the IoT market is growing. And as we can see in this graph, it continues to grow steadily, and it is projected to grow at an at least 20% compound annual growth rate for the next 4 years. Therefore, as the IoT market grows, it greatly impacts the mobile app development market as well. And the IoT implementation for mobile apps may present some technical or business challenges. That is why we decided to dedicate this discussion specifically for IoT projects. But before we move forward, I want to really quickly ask a polling question to get the idea about our audience and to understand where our audience stands with relation to today's webinar topic. Now you can see the poll appearing on your screen with the question of where is your organization in terms of IoT implementation. I'll give you a couple of seconds to submit your option and share, and I will share the results with you. So I can see that okay, a couple of seconds. Some more seconds. So I can see that the majority of our audience is planning to implement IoT solutions in the next 12 months. And the other majority just begun implementing IoT solutions. Okay, very good. I hope that this webinar will be insightful for you. And meanwhile, if you have some questions related to this discussion, please make sure to ask in the comment section, in the questions section. So moving forward, today we're going to explore the ins and outs of mobile IoT development, what's different about IoT mobile apps and mobile apps development comparing to standard mobile app development, and what roles the app plays. Our speakers will refer to some common challenges for hardware-dependent mobile applications development, as well as bringing their optimal solutions based on their experience working on these kinds of projects. And one more thing from my side, as a reminder, this webinar is being recorded and you can access it in your mailbox within a couple of hours once it is over. Well, I think this much from my side, and without any more delay, let's get started. Andranik, you now have the spotlight.
Okay, thanks, Mariam. So, as you already mentioned, IoT mobile applications, or as I prefer to say, mobile applications, which have hardware dependency on somewhere or another are becoming very popular. And these types of applications has a set of distinctive features which makes their development process different from other types of applications. Although for the end user perspective, these kinds of apps might not look any different, under the hood, they incorporate unique functionalities that can involve direct communication and interaction with specific hardware components. So let's have a very, very high level and basic overview of the processes that are going inside a typical application, like your online banking, cab booking, or news application. It usually flows in a quite straightforward direction where the application usually has a single source of truth, the backend services, and it communicates with those in a well-defined and widely adopted RESTful API standard over the internet and HTTP protocol. By saying this, I am in no way undermining the challenges that are being solved in typical server-to-client applications, just want to outline the difference that hardware-dependent applications have. Now, in case of a hardware-dependent applications, the things can go in different scenarios, and there is usually no solution that can fit for all cases, and each use case may require a unique approach and solution. Maybe the simplest form of a hardware-dependent application communication can be illustrated like this. As you can see here, we have different communication protocols. So Bluetooth Low Energy, Bluetooth Classic, Direct Wi-Fi, all these are different ways to communicate with a device. For example, your wireless headphones are connected to your phone through Bluetooth Classic, but a smart thermostat can be connected through Bluetooth Low Energy. Or, for example, while onboarding a smart vacuum cleaner in most brands, it's asked to connect to its Wi-Fi network to do the initial configurations. Now, that is a direct Wi-Fi, etc. And already from here, it's obvious that here we have a lot of different ways to communicate with peripheral devices. And these are not choices that we are free to choose whichever we like more. It usually depends on the peripheral device itself, its purpose, and usually this choice comes as a requirement to the mobile app development team from the hardware design and development team. Also, it's worth mentioning that in usual client-server applications, in most cases, the actual data is transferred as a JSON data structure, which is way more developer-friendly and easy to understand with the naked eye. But when communicating with the device, this can be very different. For example, in case of Bluetooth Low Energy, the data is a raw byte array transferred back and forth in small chunks in some protocol, for example, UART. And believe me, looking at a raw byte array is a lot less informative than the friendly JSON data structures. But for instance, in case of direct Wi-Fi, it can be JSON as well, so it really depends. Moreover, as opposed to the client-server communication apps, where the remote party, the backend services, is usually one and known during the build time of the application, in case of a peripheral device, there are discovery and pairing processes involved, where again, there is no single defined protocol of discovery, and depending on the use case, a totally custom solution may be required. It's worth noting that our simple app, which just communicates with a peripheral device, can become something like this, shown in the slide. Here we already need to communicate with backend services and peripheral devices simultaneously by syncing data from one to another. For example, your smartwatch is connected to your mobile phone and constantly communicate with it via Bluetooth Low Energy, but it also sends information to the backend through the mobile application. In such scenarios, the mobile application is not only performing the role of the user-facing part of the system, but also acts as a mediator between totally diverse parties, each of which communicates with the different protocols and data structures, where each of them can be unreachable in a particular moment of time, etc. It also worth noting that there can be multiple peripheral devices which can make things even more complicated. For example, you could have smart light bulbs all over your house and register all of them inside the app. And you will need to be able to control these bulbs and see their statuses. In this situation, the mobile application must keep track of all devices to detect from which device it receives a message or status update. The mobile application should handle the situation when it receives a command from the user or from the backend service, for example, that needs to be addressed to one of the connected peripherals. Also, it should keep track of connection statuses, connection signal strength of all connected devices, etc. And in another use case, there can be a smart device which also acts as a hub and can have child peripherals connected to it. And mobile apps should communicate to the hub itself and to the child devices through the hub. Sometimes there can be the possibility to communicate and connect to the peripherals directly. Like, for example, in a smart home system, when many elements of the smart home can be connected and controlled individually, but also all of them can be connected to a central hub and be communicated from there. And in another use case, this hub can be somewhere in the cloud, and both the mobile app and the peripheral devices should communicate through the internet to the hub to be able to send messages to each other. This list can be continued with more and more examples where things can get even more complex. But the main idea here is that whereas in case of usual server client applications, the mobile app is the last link in the system chain. In IoT projects, it suddenly becomes in the middle of the chain, connected to diverse parties with different communication protocols and need to leverage from this perspective.
So far we can deduce two of the main. So what we've discussed so far, yes, we can deduce two of the main challenges that IoT-related mobile apps face. First is communication channels and protocols, and the second one is the role and responsibility of applications itself. Right?
Right, and later we'll illustrate a few more practical examples of those challenges by using some of the projects that we worked on.
Okay.
Maya, also there's an end-to-end testing and reproduction of bugs happening in certain conditions of such applications, as it's usually hard to create all necessary conditions for peripheral devices to cover all possible scenarios. And let me bring some examples. So, for example, if we have a requirement to change a color in the app if the CO2 concentration in the room is above a certain level, well, it is not so easy to increase and decrease CO2 level. Or for example, if we need to test a certain behavior of an application that controls smart vacuum robots and needs to reproduce a bug that happens in the app when the battery of the robot is below 10%, while the robot is cleaning the room in an intensive cleaning mode. Or another such example, imagine you're creating an app which controls a drone, and in certain situations, the app should inform the drone to take off and go up to 500 meters, then go to a location picked on a map, record a 2-minute video whereby turning around and come back. Well, this is impossible to test in the office, right? So I guess you understand what I mean. And to solve these kind of issues, we need to perform various levels of mocking and simulations. And for example, in the case of CO2 example, we can develop a simple page which just shows the raw reading of the CO2 from the sensor. And this can be tested once in various conditions with another production-ready CO2 sensor to make sure that the correct sensor readings are being transferred to the app. And then inside that, we can move the result of the readings to correct and test the color changes. And in another case, we might need to create a full functioning simulator of the peripheral device itself to solve proposal, which will be to help the dev and QA teams mock the different states of the device. And although this is not the final list of the challenges and differences that come with IoT mobile apps, these are some of the most notable ones.
Okay, in that case, we can start discussing few practical use cases and challenges you guys met when dealing with IoT mobile apps. Yep.
Of course. So let me start with the story of air quality monitoring device app development. So the aim of this project was to make a wearable device which will be connected to the mobile phone of the user through Bluetooth Low Energy, like for example your smartwatch does, and notify about the air quality sensor reading. And in case of an abnormal levels of some of the gases in the air, the device will start alerting the phone, which should set off an alarm for the user. And here in the diagram, you can see the communication protocols, etc., involved in this project. So there is an AQM device which holds different sensors. It's connected to the mobile app through Bluetooth Low Energy, and the mobile app also has a connection with a backend service. The mobile app acts as a mediator and was sending the readings it got from the AQM device to the backend services. It was also aggregating the readings to its local database. As the memory of the wearable device was very limited, it could not accumulate too much of historical data. So as we can see, the data management part here was quite complicated. The communication with the device was done via UART protocol over BLE, Bluetooth Low Energy. This was the solution, let's say, and the challenges that we met during the development of this project were as follows. When the development of the mobile application reached to the point where the real device was needed to be connected, the real device was not yet assembled, as it can happen with any hardware device that is just being designed and assembled for the first time. However, the entire communication protocol of the app and device via UART protocol was documented, which helped us to create another Android application which was simulating the expected hardware device. And with this simulator, we were able to develop 70% of the application until the assembly of the real hardware was finished and shipped to us. And even after we had the real device, we were using this simulator for testing some extreme situations, which is hard to produce with real sensors. And another challenging part of this kind of app is the need to provide ways to upgrade the firmware on the edge device, on the sensors. So thankfully, there is a protocol designed for that part, which is called DFU, which stands for Device Firmware Upgrade. And we used it together with our custom logic to handle the firmware updates.
Andranik, so do I understand that correctly that this solution enables users to gain control over their health by just tracking the quality of the air they breathe in?
Yeah. So if they see the quality of the air is bad, people, for example, with asthmatic symptoms should leave that area, location, etc.
From user perspective, such a helpful solution.
Yeah.
Madam, let me share another helpful solution for this industry. We had another interesting case for a client in the healthcare industry who wanted to provide a comprehensive set of solutions to help patients get control of their well-being. And here there were several connected devices to account for. Medical alarm speaker and virtual assistant that has many functions like reminding patients of their appointments, answering health questions, sending notifications to family caregivers, and more. A medical alert watch that keeps track of patients' health with such features as a pedometer and a heart rate monitor, and the medical alert pendant with built-in fall detection and emergency help button. Now, the role of the mobile app here was that of an admin controller to configure the settings for all of these devices. And the challenge here was that some of our IoT devices came with a built-in cellular SIM card with a 4G network support, and some of them did not, such as our VOLO speaker device. And to be able to configure that device, which is not connected to the internet out of the box, we should have somehow connected it to a Wi-Fi network, so it will be able to communicate with our servers. And to solve this, we decided to establish a direct BLE connection between the app and the device, where the app is acting itself as the central and the device as a peripheral. And to initiate the pairing process, we put the hardware button on the peripheral IoT device, which starts to broadcast specific services and characteristics on long press. And after the mobile app discovers the peripheral, it reads some of identifiers, verifies the device with our server to make sure that the device is valid to register and has an active subscription plan. And in case of a success, it establishes the connection. And next, the device starts to discover nearby Wi-Fi networks and transmits the list to our mobile app. This is required because iOS devices Apple limited developers to discover nearby Wi-Fi network names due to security reasons. But on the device, we were free to make the discovery as it's running on Android. And the list then was displayed to the user in the mobile app, who selects one of the available networks, enters the password, and transmits those credentials back to the device to connect it to the selected network. And in case of a successful connection, the device changes its network connection status broadcast while, which acts as the acknowledgement of the connection. And now that we connected the IoT device to the network, it is able to communicate with our cloud services autonomously using RESTful APIs and completes the rest of the necessary configurations, which are crucial for our product, such as push notification configuration, which serve as a tool for pushing time-sensitive and critical information, such as medical reminders or appointment reminders to the devices.
Okay, the examples you just shared with us demonstrate some clear benefits of IoT in healthcare sector. However, I would like us to shift our focus to another industry that has also seen a transformation through the application of IoT. That is agriculture with its different sectors.
That is Mariam, and let me share with you one of my favorites from agriculture sector. So this IoT solution was for farmers to track the plant status, to help them to immediately get aware of the plantation conditions and monitor the expected production. For their business, checking every plant is essential to see the growth and the potential problems that need to be countered. And since this task is difficult and takes much of the workforce and time, our client wanted us to develop a drone control application for plant monitoring. In the following use case, we created a mobile app which would run inside an Android-powered remote control of the drone, use a specific SDK provided by the manufacturer to control drones of a certain types and set schedules and execute missions on drones. From the other side, the app was connected to a web portal through the backend services. In the web portal, operators could see status of connected drones and execute missions on them. For example, a mission could be to take off, fly over field 1 at a certain altitude, take pictures every 1 meter, fly back and send the pictures back to the web portal. At the same time, drones could receive interactive commands to increase altitude, fly back, take an instant image, etc. And also, we're syncing their telemetry data back to the web portal. And the mobile application was right in the center of this system. It was taking missions and commands from the web portal and orchestrating them to the drone, etc. And the main challenge here, well, I guess you got it. Drones can be very unpredictable when you mess with their SDK directly. And of course, we also needed to make sure that we are not tying our solution to one manufacturer and can easily scale by supporting different manufacturers with different SDKs and drone remote controls.
In that case, let's make a safe landing from aerial operations. What about greenhouses or warehouses, plantations monitoring? Because drones cannot fly inside the greenhouses, right?
Right, Maida. And for that case, we had another project for greenhouse control and monitoring. And during this project, we designed and developed a complete solution for monitoring greenhouses and assigning everyday tasks to the farmers working in the field. And one of the challenges in these kinds of projects is that the fields are usually out of the range of the mobile network, and creating Wi-Fi coverage all over the field is also not feasible or too expensive. So only one controller machine per several fields was designed to act as controller and gateway for tablet applications, which connected to it through direct Wi-Fi connection and synced with it to get everyday assignments when farmers should go to the fields with their task in the tablet, complete them and take some measurements and take pictures and create reports completely offline. And only at the end of the day sync the data back to the controller.
Okay, thank you so much for sharing this insight, guys, because demonstrating with practical scenarios always enhances understanding. And I'm sure there's a lot to share, but let's save those for the next time. But if there are still some questions related to this topic or mobile app development in general, just make sure, dear audience, to reach out to us. We will try our best to provide you the right and the most useful answers. And for now, I think that's much, and I hope this webinar was insightful for you. And thank you so much for your time and interest. And I wish you a great day. And bye bye for now. Bye, guys.
Bye bye.
Bye, guys.